Okay, welcome to the next lesson in our AQA GCSE Physics Specification course. I'm doing a series of lessons on electricity. Okay, right. We're going to be looking at resistance and Ohm's law in this lesson. So, what is Ohm's law? Well, it is a resistor or device that is said to be ohmic or obeying Ohm's law will have the current being directly proportional to the voltage across the component. Okay? And there's one important practical that you've got to be familiar with. I'm going to draw the circuit diagram for you. Please screenshot this or freeze the video for this definition. Okay, so I'm going to rub this off now. So, the diagram I'm going to draw, have a battery, I'm going to connect it to an ammeter and have a variable resistor. Please watch my video on circuit symbols if you're unfamiliar with these. Okay, then I've got another resistor here, and I'll put a switch in it in the circuit as well, and here's my voltmeter. Okay, now let's explain what this circuit, how this experiment works. Well, I'm going to have a table of current values and voltage or potential difference values, okay, somewhere in my exercise book, okay, and I have my variable resistor, okay, this is what a variable resistor looks like, okay, and again, this can alter the amount of, this can change, can vary the resistance in my circuit. And basically, what is it made up of? It's just a coil of wire, a long coil of wire, and as I move this slider across, I can change that effective length, and I can change the amount of resistance that the electrons have to overcome in order to get to the other side of the circuit. Okay, how does this experiment work? Well, when I close the switch, I'm going to get a voltmeter reading, and I'm going to get an ammeter reading, okay? And what is my independent variable? Okay, what am I going to change? Well, I'm effectively going to change my resistance here, okay? Because that's going to alter my current passing through my circuit and also the voltage. So, if I were to do this experiment, and obviously I would turn on and open and close the switch every time I move my slider across, I vary my setting for my variable resistor. So I could get values like this. Okay. And notice these values are proportional to one another. Okay. So this is going up in ones, this is going up in twos, but they're proportional to one another. And therefore, and if you did this experiment, and if this external resistor was said to be ohmic, and I plotted my current values there, and my voltage values here, so this is voltage, V, this is current, measured in amps, okay? The fact that I've got a straight line like this, and obviously I would have plotted my points. Okay, so my voltage goes up 2, 4, 6, 8, 10, 12, and so on. This is 1, 2, 3, 4, 5, and so on. It's my origin point. This is said to be a linear, direct, proportional relationship between current and voltage. And this is obeying Ohm's law. Okay? Well, one thing I forgot to say in that definition, Ohm's law is when current and voltage are proportional to one another at constant temperature. Okay? Because this gradient will change with temperature as well. Okay, so what is this measuring? Well, V is equal to IR. So if I make R the subject, R is V over I. So the gradient in this case, if I was to draw a triangle, so gradient is change in Y. So basically this length, so this number minus this number divided by my change in X. So this number minus this number, if I did that, I would get my gradient. Okay, so my gradient would be, in this case, I divided by V. So my gradient is equal to I divided by V, because my I is my change in Y, because this is my Y-axis, and my V is my change in X. But I want resistance. Okay, so basically it's the reciprocal, which is basically this flipped around. So my gradient, what I mean by that, my resistance is equal to 1 divided by gradient, or this is equal to, my gradient is equal to 1 over resistance. Okay, so this experiment allows me to work out the average resistance of that component that I'm testing, okay, by getting a series of current readings and a series of voltage readings, and then I work out my gradient. According to this graph, I do 1 divided by that, and then I come up with my resistance. Okay. Alternatively, if you didn't want to do all that complex maths rearranging, I could have simply put my voltage on my y-axis and my current on my x-axis. Okay? Because then, look at my change in y now. It's V divided by change in xi, and that's my resistance. Okay? So, it's entirely up to you how you do this experiment, but for your exam, you need to be able to, first of all, draw the circuit diagram, okay, and produce a method, okay, for this experiment. I'm going to briefly do a couple of bullet points for the method now, okay? So, I would say, first point, set up circuit as shown. Okay, I won't redraw the circuit, but if you rewind the video, that original circuit is perfectly fine. So set up circuit as shown, close switch, and set slider of variable resistor to one side. Okay? So I've set it to one side like that, so it's low resistance at the moment, or high resistance depending on which side you started from. Okay, I would say record ammeter and voltmeter readings. Okay, next step. Adjust slider so on variable resistor Okay, so what have I said here? I said adjust the slider so we have a new resistance, external resistance in the circuit, okay? Because that's going to change our current flowing through the system, and obviously that's what we want to do. We want to have a range of current values which will give us a range of voltage values. Okay, I'm going to rub off 1 and 2. So, what have I ended up with? So, adjust, yeah, again, 5, record, new ammeter, and voltmeter readings, and I was going to say in table. Okay. Then I would say step 6, repeat steps 4 and 5 for another 5 settings of the variable resistor. So, why have I said another 5? Well, so that we can have a good range, because each setting that we change, we get a different current and a different voltage reading, and that's what we want. Okay? And I would say step 7, plot a graph of voltage versus current, and I've chosen to do voltage this time on the y-axis and current on the x-axis to make our lives a bit easier, or your lives a bit easier, and to have a shorter series of steps here. Plot a graph of voltage versus current. Draw a line of best fit. Draw a line of best fit through the data points. Okay, draw a line of best fit through the data points. Step 9. Work out the gradient, which is rise over run, change in y over change in x. This is the resistance of the component. Okay? The average resistance of the component, because we've obviously taken a range of current values and voltage values. Okay, hopefully that makes sense. Again, please do pause the video, take screenshots of any of these steps. But again, these are my own words, so please do them in your own words. But the basic principle is set up your circuit. You want an ammeter and a voltmeter in it. You want a variable resistor. You change its settings several times, give you 8 or 10 values, so you get a good range of current and voltage values. Plot a graph, voltage on the y-axis if you want, and your current on the x-axis. Draw a line of best fit, gradient, and that's your resistance. And there you go. Hopefully that's helpful, and wish you all the best.